Hi, in this video we're going to explore the NurbsSurface class in RhinoCommon, which gives us a lot more options to create surfaces than the Surface class does. So in the RhinoCommon API we can search for the NurbsSurface class, and it inherits of course from the Surface class, and it has almost the same properties and the same methods that the Surface class has, plus some methods and properties. In order to create a NURBS surface, you can create it by copying another NURBS surface, that's all, or you can use the methods. And when you want to use a method to create a NURBS surface or a surface, just check the create, the methods that start with the create word. So you can create it using an extrusion, and this gives you actually a surface and not a NURBS surface. So it gives us a surface, so it's inherited from the Surface class as we said before, but we can create a surface from corners. So the Rhino components creating a surface from points, you can find it here in the NURBS surface. You can create it from corner points or from a set of points, or you can copy or make a cylinder a NURBS surface instead of a cylinder object, or a sphere to be a NURBS surface instead of being a sphere, and so on. So let's try to construct a NURBS surface using first corner points. And if we open this, we need to add 4 corner points, point by point, and it's a static method. It returns a NURBS surface. So let's try this. We need to add 4 points. So let's add a point and set 1 here and copy it. So here we have 4 points, and let's move this one a bit and move this one to here and move this one here. So let's add these points now. So pt1, and that will be a point 3D object, and this will also be a point 3D object called pt2 and pt3. And finally pt4, and here we make it a point 3D. Let's connect them here, and now our inputs are ready, and all we have to do is create a NURBS surface, and that will be called surface A again, and it will be equal to NURBS surface dot create from corners, and we'll pass here our 4 points, which are pt1, pt2, pt3, pt4. And if we run this, we need to set the output A to be surface A. Now our surface will appear here. Okay, we have a problem here. The name A does not, oh, this should be capital. Now it works, and it gives me this one, but why? Okay, this should be 0.4, not 0.3, and now we have this surface here. That of course changes if we change the point location. So this is our very first method. If we want to create a NURBS surface from points, which is actually this very Rhino component here, which is surface from points, I think it's called like this, yeah, here, surface from points. How can we do it? We need to add a U count and an we need to add a U count and a point list. So in order to create a C# component that does exactly the same, all we're going to do here is copy this, add it to this new C# component. Let's close this and I'm going to preview this. This was our first component. Now we're going to add a NURBS surface dot create from points, and here we need to add a point list which will be called points. Need to add a U count, a V count, a U degree. Let's make it 3 and 3, and that's it. Okay, so actually a surface from points is usually created using a grid of points, so usually deal with it as a surface that connects a grid of points. And this means that if we have 3 rows of points, this should the 4 rows should have the same number of points, the 3 columns should have the same number of points. These are what we add to the U and V count. So the U count will be the number of points in the U direction here, and the V count will be the number of points in this direction, which is 4. That's why we have to make sure that the number of points in all the rows is consistent, and the number of points in all the columns is also consistent. So we need to add here the points list, and we need to make sure that it's a list access and that it's a point 3D. Okay, now we can add the U count, and that will be an integer, and the V count, which will also be an integer. So let's add a list of points. Let's hide these and add here multiple points. So the order matters. It means that if I'm going to use the points, I can't just go to the right. I have to start from the first. I have to start from the first of the from the first row again each time I'm drawing a point, because this will change. Actually, this will change how the surface is formed. I will show you that. But if we add the points here, and we want here we have the U count is 3 actually, and the V count is 3 as well. Now it created a surface. If I want this to be a 1 degree surface, I will just change these and it will connect it with sharp lines. Okay, so what happens if we draw the points in a wrong order? So let's say we set multiple points and we draw them this way. What happens is a surface that is not quite right. It will follow the points order, so it will start from here going to this point, and then it will go to this point, and so on. Of course, the points are not necessarily do not necessarily form a clear grid, meaning that this should not be exactly on the same x value of the upper points. No, we can change these as we want. We can change the points place to whatever we want. But it's also important to understand that creating a surface from points, the surface is always created on the plane. So if I move this point to the up, this will not be a smooth surface unless we change the degrees to 3. And here we can find that moving the point actually creates this smooth, nice surface. Okay, yes. So let's try some methods on our created surface. So we can get, of course, the points with the same way, I think. So if we get the points of the surface, it turns a NurbsSurface point list and this NurbsSurface point list class should be accessed by Rhino, the geometry, the collections, the NurbsSurface point list. And to get a certain point, this returns a point list object, and to get a point we have to output the point 3D point using get point. Okay, it's exactly the same that happened with our curve class. We can get the closest point, of course. Let's try that. We can type point 3D point A equals surface A dot point at dot closest point, I mean, and inside the closest point here we need to add a test point and output U and output V to get the parameters of the surface where the point is located at. And we need to create the W and double V, and here I want to try something. Actually, I want to try this to be out double V and W instead of creating this. Okay, it doesn't work. We have to create the U and V at first. So let's add B as point A, which is the closest point on the surface to the test point that we're going to add here, and that's test point, and it's 3D point 3D. Let's create this point. We'll set one point here and add B here, and that should be it, but we have a problem. Okay, so yep, this doesn't return a point 3D. It returns a true or false value. So we should have said Boolean closest point equals this, and then we'll use the U and V values in order to get the point on the curve, so on the surface I mean. So point 3D point A equals surface A dot point at, and then we'll pass the U and V values that we got from the closest point, and this should run. Yep, so this is the point B actually here. Yes, and if we move this point, we find that the point on the surface changes to the closest point to the test point on this surface. Okay, again, we can create an extrusion. As said before, we can create a lot of things here. We can change the domain. We can extend the surface using a direction and an interval. We can extend it using another way, so an edge and extension length and a true or false value for smoothness of the surface. We can get a frame at certain values. Let's get the frame at this. Let's try this. We didn't try it before, so we'll say directly that C equals surface A dot frame at U and V and out frame, and actually frame is a plane. Okay, we're not going to do this way. We are going to set here a boolean. So boolean A equals surface A dot frame, and here we have to make a variable called frame that is a plane, so plane frame. So the output of this dot frame at method is saved in the plane that is called frame. So if we write here frame, this should work. If we run this and add C, yes. So it gives me the frame at this very point. Okay, what else can we do? We can get a bounding box. Okay, let's try getting a bounding box. We want to try as many methods as possible in order to make this video helpful. So it returns a bounding box, and if we want to create a bounding box, we created using the bounding box class, I think, or struct. It's a struct. So we will use .get bounding box and boolean. Okay, so we'll do it using our object. So bounding box b box equals surface a dot get bounding box, and inside we'll say true, and let's add d that is equal to b box and try and see if this works. Hopefully it will work. Yes, so it's a bounding box that contains all of the surface here. Yep. So what else can we do? We can get the next discontinuity. We can create an interpolated curve on the surface using some points and the tolerance. I think this is straightforward. We can check if it's a lot of things. We can get the normal at the u and v. Let's try this. Also, this will be easy. So the normal should be a vector. So vector 3D normal equals surface a dot normal at, and we pass the u and v values of the point that we got, the closest point that we had. Let's just remove the b box now and see what happens. So this is the vector called normal. We'll add here e equals normal and add it to the outputs, and let's try showing this vector now. So we'll use the vector display component. Our anchor will be the point at the curve, which is this one. So this will be our anchor, and this will be our vector here. So this is the normal at this point. Okay, we can rebuild, as we said, the surface. We can reverse the direction of the surface, and this should return a boolean value. I think no, it returns a surface that is reversed. We can rotate it, scale it, set its domain. We can convert it to a brep or to a NurbsSurface. It is already a NurbsSurface, so this is a method that is inherited from the surface class. We can translate it, we can transpose it. It means swapping the u and v. We can try and get a cylinder out of this surface, or a plane, or a sphere, or so a lot of things. That's it for the NurbsSurface class. I hope you've enjoyed this video. I hope it was really helpful and entertaining to you. See you in the next video. Thank you.